Determine the force in each member of the truss. State if the members are in tension or compression. First thing I'm going to do is find any zero force members. Now if we look at this joint C here, the DC and CB are in a direct line. So if there were to be a force perpendicular to that, or even a component of a force perpendicular, which AC would have, it would have to be countered by another force. Otherwise, joint C is going to accelerate that direction. And since there's no other possible force, then this one must be a zero force member. And so looking at this truss, we have a horizontal reaction there, AX. We have a horizontal reaction there, BX. And then we could have a vertical reaction, BY. So we can start by summing the moments about A to find BX. So sum the moments about A, and we get 300 times 4, and we get BX. Now I'm guessing actually BX is going to be going this direction, so let's do it that way. We'll get a negative. So plus BX times 3. BY goes through A, so that's not going to have a reaction, and there's no other loads. So that equals 0, and BX equals 400. And we had to move that over, so it's a negative 400. And as I predicted, BX is pulling it towards the wall. If we sum the forces in the Y, then we have BY up, and we have 300 down. So BY equals 300. And if we sum the forces in the X, we have BX to the right, AX to the left, and no other horizontal forces, so that equals 0. And BX equals AY equals negative, well, 400 with AY that direction, or AX that direction, BX that direction. So, now let's draw our truss. So, call this BD. This was a zero force, so I'm going to omit it. So 300 here, and got a force there. We got a reaction there. Now since there's no other forces, this force in this is actually 0. So we'll put that as 0. And then we have a force there. Now let's erase the middle parts and do method of joints. So this has 300 down, so there must be a 300 up. This one has no vertical component, so the only way to counter that 300 down is a 300 up there. By geometry, this is 3 to 4, so the forces will be 3 to 4, so this is 400. If that has 400 over, there has to be a 400 to the left. And now if we look at this joint, we are in equilibrium. The X is at 0, the Y is at 0. There's a net force of 0 on the joint. Now the forces continue across the member, equal and opposite on the opposing joint. So 400 here and 300 here. 400 pushing to the left, 400 pushing to the right. Now we already calculated that joint to be 400, for that reaction. So that gives us a good feeling that we know we're in equilibrium already on that joint. And on this joint, we had calculated these reactions, and then we had gotten 400 to the left and 300 up, which also puts it in equilibrium because that zeroes out and that zeroes out. So we are at complete equilibrium, and the truss is done. This one, it's pulling in from the joint, so this is in tension. It's pushing out on the joint, so that's in compression. That's it.